Welcome. Today's lesson we are going to talk about how to prove lines are parallel. So the first thing we need to discuss is the definition of converse. So the converse of an if-then statement is when the phrases after the words if and then are switched. So last lesson we talked about all of our special angle pairs. So all of our statements started with if two parallel lines are cut by a transversal, then blah, 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 blah about angles. So now we are switching that. So basically now our today's theorems, so before we said if two parallel lines cut by a transversal. Are cut by a transversal. Then blah, 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 something about angles being congruent or supplementary. So today we are doing the converse of all of those. And so our theorems are going to be if blah, 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 blah about angles, then those lines must be parallel. All right, so before we knew the lines were parallel, so we could say something about the angles. Now, if we know something about the angles, we can say the lines are parallel. So our first one is the postulate, which is the converse of the corresponding angles postulate. And it says two lines in a transversal form corresponding angles. If two lines in a transversal form corresponding angles that are congruent, then the two lines are parallel. So if I look at the picture here, this says if angle 1 and angle 2 are congruent, then my lines are parallel, L parallel to M. Okay? We have the same thing for converse of alternate interior angles. If two lines in a transversal form alternate interior angles that are congruent, then two lines are parallel. And we have an example of our supplementary angles. So same side interior angles theorem says if two lines in a transversal form same side interior angles that are supplementary, then the two lines are parallel. So if I look at the alternate interior angles, it says if angle 1 and angle 2 are congruent. So if I know this, then I can conclude those lines are parallel. For the same side interior angle theorem, the converse of it, it says if angle 2 and angle 4 are supplementary, remember that means they add up to 180. So if measure of angle 2 plus measure of angle 4 equals 180, so if this plus this is 180, then I know my lines are parallel. Okay? So let's prove the theorem 3-5. So remember when we're proving theorems, what are we allowed to use? So we have our statements and we have our justifications. And in the justification columns, the things I'm allowed to use are definitions, mathematical properties, such as addition, subtraction, division, multiplication, substitution. Okay, those are all different types of properties. And then the last thing is postulates and theorems. Okay, and the theorems you're allowed to use are ones that you've already proven. You can't use a theorem you haven't proved yet. All right, so let's get started in this one. So remember, our first statement is always what our given statement is. So angle 1 congruent to angle 2. And our justification for that is, well, it's given to us. And our goal is to have multiple statements here so that our last statement, I don't know what number it is, says line L is parallel to line M. And I'm not sure what my justification will be for that yet. But that has to be the last statement. Okay, so that's the bones of our proof. All right, so let's look at this. So if two lines in a transversal form alternate interior angles that are congruent, then the two lines are parallel. Great. So I am allowed to use postulates, and the postulate that I have that tells me line L would be parallel to line M is if corresponding angles were congruent. So if I knew before this step, if I knew that angle, sorry, I erased some of the stuff on here. If I knew corresponding angles, so angle 2 was congruent to angle 3, if I knew that, then I can conclude that L is parallel to M by the converse of the corresponding angles postulate. And I am more than happy if you abbreviate, but please make sure that you abbreviate with like 4 letters of words, and do never abbreviate substitution and subtraction, because that can be a little confusing. Okay, so now our goal is to get from angle 1 congruent to angle 2 to then say angle 2 is congruent to angle 3. Well, I don't know those lines are parallel, so I can't say 2 and 3 are congruent right away, but I do know that 1 and 3 form vertical angles. So 1 is congruent to angle 3, and that's because vertical angles are always congruent. Then, from there, I have my good old friend substitution. If angle 1 is congruent to angle 2, and angle 1 is congruent to angle 3, then 2 and 3 have to be congruent. So for that step, step 3, I would say substitution. And then my last step is, once I know that I have a pair of corresponding angles that are congruent, then I can say L is parallel to M because of the converse of the corresponding angles postulate, which is the first one on the page today. Okay, the first one we talked about. Great, let's move on. An example says, which lines, if any, must be parallel if angle 1 is congruent to angle 2? So I'm going to highlight the angles, or highlight the lines that make angle 1. So angle 1 uses line DK and line ED. And angle 2 also uses line DK, and then I need line CK. All right, so if I just look at those and I ignore that other line, it can help me really kind of see what I'm looking at. So if this angle here is congruent to this angle here, so they're on the interior and they're alternate. Okay, so these are alternate interior angles, and they are congruent. So that means that my lines that are cut by the transversal must be parallel. So this line must be parallel to this line. So if I go back to my picture, I got to erase it so I can see those letters better. So then I would have this line here would be ED is parallel to line KC. All right, I'm going to use 2 letters. So my final answer here is line ED parallel to line KC. All right, next. Now we have the converse of the alternate interior angles theorem that says if 2 lines in a transversal form alternate exterior angles that are congruent, then the 2 lines are parallel. So in my picture here, if angle 1 and angle 2 are congruent, then I have A parallel to B. And if 2 lines in a transversal form same side exterior angles that are supplementary, then the 2 lines are parallel. So if angle 1 and angle 3 are supplementary, then A is parallel to B. All right, so let's do proof 3.7. So if 2 lines in a transversal form alternate exterior angles that are congruent, then the 2 lines are parallel. So before we said 2 lines are parallel, and we used our postulate that said corresponding angles. And so if I look at this picture, I can see I also have corresponding angles labeled again. So the picture can give you some clues as to which angles you might use. So if they don't have an angle labeled, you're probably not going to use that angle in your proof. It doesn't mean that there's not a correct proof using an angle that's not labeled. It just means it might not be the most efficient way. All right, so they label the pictures to give you a clue as to the most efficient proof possible. Okay, so we got our statements. We got our justifications. Step 1 is angle 1 congruent to angle 2, and we know that because it's given to us. Step 2, let's just kind of look and see. If I have angle 1, what information do I know about angle 1? If I just look at angle 1, well, what's its relationship to angle 4? Vertical angles. So I'm just going to write that down. Maybe I might need it, maybe I won't, but they're congruent because their vertical angles are congruent. Then, what do I know about angle 4? So I've included angle 4 in the mix. If I look at angle 4, we already know its relationship to angle 1, but we also know angle 4 and angle 2 are congruent. If they were congruent, right, then we would have vertical angles. And so do I know they're congruent? Well, I in fact do know they're congruent because they're both congruent to angle 1. So once again, we have our good old friend substitution. So angle 2 is congruent to angle 1, which is congruent to angle 4. Therefore, angle 2 and angle 4 must be congruent to each other. So that's substitution. And now I can say, hey, if corresponding angles are congruent, which they are, 2 and 4 are corresponding, then my lines must be parallel. So A parallel to B. And the reason for that is converse of corresponding angles postulate. Great. So go ahead and